SpongeBob SquarePants. 6.5, Radical Equations. So that title sounds really cool, but it's literally equations with a radical sign in it. But that is kind of fun for me too. All right, let's look at some square root equations. When you're solving square root equations or when you're solving radical equations, you want to try to isolate that root as much as possible. So for example, we have this example. There's a 3 that's not in the square root. Let's try to bring that 3 away from the root, bring it to the other side by just subtracting it to the other side. When we do that, you have square root of 2x minus 3 is equal to 5. All right, so what do you think you're supposed to do now? You have to get rid of that square root. How do we get rid of a square root? It looks like to get rid of a square root, you do the opposite. You square the whole equation. So what you do is you put the whole thing in parentheses and square it. And then remember, with equations, whatever you do to one side, you have to do to the other side. So put the 5 in parentheses. Not really necessary, but just to stay consistent, and square it. So that square actually cancels out the square root. And so we're going to have 2x minus 3 is equal to 25. And now it becomes a super easy equation. Add 3 to both sides, divide both sides by 2. All right, so that's how you do square root equations. Let's do another one for fun. Again, the main thing you want to do is isolate the square root. So that minus 5 that's right there, get rid of it. Bring it to the other side. You add it to the other side. So now it's x plus 5 on the other side. Now that the square root symbol is isolated, you can go ahead and get rid of it by squaring the whole side. So this is when the parentheses does matter. You square the whole side. Well, this squared cancels out that square root, but this square you actually have to FOIL. You have to FOIL it. You can't just say x squared plus 25. You have to put x squared. You have to put x plus 5 and x plus 5, and then FOIL it. Here's what that looks like. All right, the left side, the square root is gone, but the right side, I FOILed it. I mean, I skipped a few steps, but FOIL. Outside, first, outside, inside, last. Now, if you recognize, we have something called a quadratic equation. Ugh, you have x squared, quadratic equations. That was a couple of chapters back. To solve quadratic equations, we have to set the whole equation equal to 0. So try to get it equal to 0. Bring the x to the other side, bring that 7 to the other side, and you get 0 equals x squared plus 9x plus 18. And then from the chapters before, you actually know 4 different ways to solve this quadratic. And it's your choice. You can either factor it, put it in parentheses, you can use completing the square, you can graph it, or you can use the quadratic formula. Whichever way works, use that way. I'm going to go ahead and use factoring. It's usually the easiest way, but that doesn't always work. But in this case, it actually did work. Once we factored it, you just set each parentheses equal to 0 using the zero product property. Our two answers is x equals -6 and x equals -3. All right, so that one was a little bit more complicated, but still pretty fun to do. What about higher roots? Notice this is no longer just a square root, but it's a 5th root. Makes it a little bit more interesting, but still doable. Same thing, you want to isolate the root. You want to get rid of everything around it. So then if you notice, there's actually a few things around that root. You have a 3 in front of it, and then you have a 1 behind it. So which do you get rid of first? Just like in regular algebra, you're going to get rid of that 1 first. Bring that 1 to the other side. It becomes a 24 now on the other side. Now get rid of that 3 by dividing both sides by 3. All right, and now we just have the root. All right, at this point, it gets a little bit tricky, but not too bad. We have a little 3 here, and we have a little 5 there. So the 5th root, and then the cube. And then, so we have to figure out which of those two do you get rid of first. And it's actually your choice. You can get rid of that little 5, the little 5th root first, or you can get rid of the 3rd power first. It is your choice. But in general, it is going to be easier if you get rid of the power first. If you get rid of this little 3 first, just because it'll produce smaller numbers. All right, so how do you get rid of a 3rd power? What's the opposite of a 3rd power? The opposite of a 3rd power is a cubed root. All right, you have to cube root both sides. All right, so cube root means you put a little cube root next to the x and a cube root on this side too. That cube root actually cancels out that little 3. All right, and then the cube root of 8 is 2. I'll clean it up to make it look nicer. So cube root both sides, and it gets rid of that little 3. Now we have to get rid of this 5, this 5th root. How do we get rid of a 5th root? What's the opposite of a 5th root? The 5th power. To get rid of a 5th root, you raise it to the 5th power. Same to both sides, 5th power. All right, that 5th power will cancel out the 5th root, and then 2 to the 5th power is 32. And then from here, super easy, x equals 31. All right, let's move on. What about even powers? You have to be careful with equations with even numerators in the exponent because they can get you can get multiple answers from them. For example, this equation. Notice what we're talking about is this right here. It is an even number, so when that's an even number there, you have to be a little bit careful because you're going to probably get 2 answers. But let's go ahead and solve it. First thing we got to get rid of is this 3 that's in the front. Divide both sides by 3. There we go. And now we have a choice to get rid of this little 2 first or to get rid of this little 3 first. And I told you earlier that it is going to be a little bit easier if you get rid of the 2 first. All right, so to get rid, that actually went on, but to get rid of the little 2, it is a square. You're going to square root both sides. The square root cancels out that little 2, and the square root of 4, whenever you square root something, back in Algebra 1, you have to make it a plus or minus. Okay, and that's the tricky part. When you square root both sides, it becomes plus or minus. All right, so there we have it. Now we get to get rid of this cube root. To get rid of a cube root, we raise it to the 3rd power. You cube it, both sides. But before we do that, the plus or minus, sometimes it might be easier if you split it into 2 different problems like this. One with a positive 2 and one with a negative 2. Now we're going to get rid of this little 3 by cubing both sides. When you cube both sides, the little cube root cancels out that cube, and then the 2 cubed gives us an 8. And now we have a pretty simple equation, x equals 7. Oh, I forgot to make that red. Same thing here. Cube it. You should get x plus 1 is equal to negative 8 now. Subtract 1 from both sides. We get x equals negative 9. All right. kind of tricky. These equations are definitely a lot more difficult than your regular Algebra 1 equations. This one says tricky, but it's not too tricky. This one just has, instead of having the root, they write it in exponential form, that 2 over 5. All right, so you should be able to change the 2 over 5 to make it look like a root. And then again, get rid of this 2 in the front by dividing both sides by 2. Let's get rid of this square by square rooting both sides. Again, when you square root both sides, don't forget about the plus and minus. This is when you can split it up into two problems, one with the positive, one with the minus. Now let's get rid of this little 5. The opposite of fifth root is fifth power. So fifth power both sides. We should get this. And we have x equals 29. And let's do it for the other one too. Fifth power to both of them. And then subtract 3. All right, it gets a little bit getting used to. Let's do one last example. Ooh, this one has 2 radical signs in it, which makes it very difficult to do. But in general, the rule says to separate the roots on opposite sides. So right now we have both of the square roots on the same side. We're going to try to move one to the other side. I'm going to go ahead and move this one to the other side. How do we do that? You just add it to both sides. Ooh, that looks messy. All right, when you add it to both sides, this is what it looks like. Okay, so now we've separated the roots. Now we can first get rid of this square root by squaring it. And then you have to do it to the other side, but to the other side you have to actually put it in parentheses and square it. Because this side now has 2 of them. The left side, actually, the squared cancels out the square root. And so now we have 2 of these guys that you have to FOIL, which is not the easiest thing to do either. You have to remember to do FOIL first, outside, inside, last. All right, so let's FOIL that. Here we have it. The only thing you might want to be careful with is that last one. How did I get x when you have x squared? I mean the square root of x times the square root of x. When you have 2 square roots and you multiply them together, the square root goes away. That's why it's just x. All right, and then from here we can combine these 2 in the middle to get 2 of them. And then now, notice we started off the equation with 2 square roots. Now there's only 1 square root. This one. Now we have to isolate that one. So bring everything to the other side. Let's go ahead and bring this 1 to the other side by subtracting it. It goes away. Let's bring this x to the other side by subtracting it. It goes away. And then if you wanted to, you can also bring the 2 to the other side by dividing both sides by 2. We have that. So now we successfully isolated this square root. Now you can square it. Those are supposed to be parentheses, which means you have to square both sides. Here's what that looks like. And now if you don't want to work with fractions, you can actually move that 4 to the other side by multiplying both sides by 4. And then we have what looks like a quadratic equation, but it doesn't look like a quadratic equation, but there is a x squared there. So let's put it into the right form, setting it equal to 0. bringing that 4x back over. So it seems like this problem is bringing stuff over and then bringing it back over and then bringing it this way and then bringing it that way. So there's a lot of just going back and forth. But yes, that does happen. All right, and so from here we have a quadratic equation. You can either factor it, use a quadratic formula, graphing it, or completing the square. But in this case, I'm going to just factor it. I'm going to pull out an x. And then from there, I get my two answers, x equals 0 and x equals 4. All right, that wasn't the easiest thing, but we're going to have to practice a lot of these equations. Just like in Algebra 1, your Algebra 1 teacher gave you a ton of homework just to solve. So that's what we're going to have to do with these radical problems, is solve and get used to solving them, all right? So go ahead and try the homework.